a times f of x minus h plus k for a equals negative 4, h equals 3, k equals 4. What function do we get and how do we graph it? Well, plug in, for the function y equals f of x equals 2 to the x. So plug in these values, we get negative 4 times f of x minus 3 plus 4, just plugging in negative 4, 3, and 4. And that's then negative 4 times what? F of x minus 3. F of x is 2 to the x. If we replace x by x minus 3, we get 2 to the x minus 3. So here's our function. Now, question of how we graph that. Well, we start off with the graph of y equals 2 to the x. And then in orange here, we sketch the graph of y equals negative 4 times 2 to the x. Now, how do we construct this graph? Well, for any point on the graph, this is going to multiply the y-coordinate of the 2 to the x function by negative 4, which means y is going to become 4 times as great, but on the opposite side of the axis. Well, what is the value of y at, let's say, this point, or for this value of x? Okay, the value of y is this, represented by this arrow. To multiply the equation by negative 4, well, we first turn the arrow around for the negative, and then we write 4 up, and puts us at a point down here. Okay, similarly, for this point, we do 4 arrows of the same length in the opposite direction. The arrow running from the x-axis to the graph point, representing the value of the function. And we get a function whose value is negative 4 times as great. And this is a vertical stretch by factor negative 4. If you prefer, technically it's a vertical stretch by factor 4, then a reflection through the x-axis. But I prefer just to take the action of the negative 4 as a single operation. You can do it any way you want. Okay, well anyhow, we do that for a series of points and we get this curve. Then, what do? X has been replaced by x minus 3. So this would have been negative 4 times 2 to the x. If we change x to x minus 3, then the x values have to be 3 units bigger to give us the same y value, which means that the graph is going to move 3 units to the right. So we draw a bunch of arrows from graph points on the negative 4 times 2 to the x graph, and at the ends of those arrows we have points on the graph of y equals negative 4 times 2 to the x minus 3. So this is negative 4 times 2 to the x minus 3. Then we add 4. If we just add 4 to all these y values, we get the graph of negative 4 f of x minus 3 plus 4. So how do we do that? Well, we just take a series of points in this graph, we draw a bunch of arrows of length 4, and it looks like these arrows are a little shorter than these arrows. They should all be the same length. But when we do this, it's going to look like this. This has length 4, this has length 4, 4, 4. They should, as I say, all be the same length. And also the x-axis, which is an asymptote to any of these graphs so far, now moves up 4 units and gives you the asymptote for this graph, horizontal asymptote. And this is how we then get the graph of y equals negative 4 times 2 to the x minus 3 plus 4. Y equals 2 to the x, multiply all the y values by negative 4. We do that as indicated. Move all the points 3 units in the horizontal direction because x has been replaced by x minus 3, and then add 4.